Hello everyone, my name is Rakshitha. I am pursuing my final year degree in Sri Venkateswara College of Engineering from the Department of Electronics and Communication Engineering. Today in this video, I'll be discussing a subject called computer networks. In this, I'll be discussing about user datagram protocol. So without any further delay, let's get into the video now. So in this slide, we'll be discussing about user datagram protocol, that is UDP. The user datagram protocol is a connectionless, unreliable transport protocol. It does not add anything to the services of IP except for providing process-to-process communication instead of host-to-host communication. UDP is a very simple protocol using a minimum of overhead. If a process wants to send a small message and does not care much about reliability, it can use UDP. Sending a small message using UDP takes much less interaction between the sender and receiver. This is the general flow diagram of the UDP. Here first the client sends the request, and if any queries are there, it will send to the server. Again, in response, the server will send it to the client again. In this slide, we will be discussing about UDP services. The general services provided by UDP are process-to-process communication, connectionless communication, flow control, error control, checksum, congestion control, encapsulation and decapsulation, queuing, and multiplexing and deplexing. Here some are the best applications of the UDP. Account for path condition and transport, implement congestion control, blaster bulk transfer application, streamline low data volume application, secure overall network. Now let's see what is process-to-process communication. UDP provides process-to-process communication using socket address, a communication of IP address, and a port number. The next is the connectionless services. UDP provides a connectionless service. This means that each user datagram sent by UDP is an independent datagram. There is no relationship between the different user datagram even if they are coming from the same source process and going to the same destination program. The user datagram are not numbered. The next is the flow control. UDP is a very simple protocol. There is no flow control and hence no window mechanism. The receiver may overflow with incoming messages. The lack of flow control means that the process using UDP should provide for this service if needed. The next is the error control. There is no error control mechanism in UDP except for the checksum. This means that the sender does not know a message has been lost or duplicated. When the receiver detects an error through the checksum, it will discard the message silently. The lack of error control means that the process using UDP should provide the needed data to be transmitted. The next is the checksum. UDP checksum calculation includes three sections: a pseudo header, a UDP header, and the data coming from the application layer. The pseudo header is the part of the header of the IP packet in which the user datagram is to be encapsulated with some fields filled with zeros. The next is the congestion control. Since UDP is a connectionless protocol, it does not provide congestion control. UDP assumes that the packet sent are small and sporadic and cannot create congestion in the network. This assumption may or may not be true today when UDP is used for the interactive real-time transfer of audio and video. The next is the encapsulation and decapsulation. To send a message from one process to another, the UDP protocol encapsulates and decapsulates messages. The next is the queuing. We have talked about ports without discussing the actual implementation of them. In UDP, queues are associated with ports. At the client side, when a process starts, it requests a port number from the operating system. Some implementation create both an incoming and outgoing queues associated with each process. The next is the multiplexing and demultiplexing. In a host running a TCP or IP protocol site, there is only one UDP but possibly several processes. To handle this situation, UDP multiplexes and deplexes are used. Next is the UDP application. UDP is suitable for a process that requires simple request-response communication with little concern for flow and error control. It is not usually used for a process such as FTP that needs to send bulk data. UDP is suitable for a process with internal flow and error control mechanism. For example, the trivial file transfer protocol process includes flow and error control. It can easily use UDP. UDP is suitable transport protocol for multicasting. Multicasting capacity is embedded in the UDP software but not in the TCP software. UDP is used for management process such as SNMP. DP is used for some route updating protocol such as routing information protocol, that is RIP. UDP is normally used for interactive real-time application that cannot tolerate uneven delay between sessions of a received message. And this picture tells the top 5 application of the UDP. So thank you all for watching my video. Please do like the video, share and subscribe to my channel. Thank you all.